Any questions about that? Alright. Today we're going to learn the double angle identity. We have about 1 week left of identities. Not really a lot of proofs necessarily. We just have a few more identities to learn. Every year I contemplate putting these in with the last test, and I just decided it would be too much material. So it's a really, really short chapter. And then next chapter we will do solving trig equations. So little bitty, 1 week, more identities. It's not as hard as the last chapter, I don't think. My opinion, I am a true teacher. I disagree with someone else. Okay, so I want to know cosine of 2 theta. I want to derive an identity for that. So I'm going to use the sum identity. I know that I could break that up into cosine of a plus a, couldn't I? Which is cosine of a minus sine of a, right? Look it up. Oh, yeah, it's okay. Cosine ones are opposite. Cosine squared minus sine squared. And so that is one angle that is equivalent to cosine of 2, or one identity equivalent to cosine of 2a. Cosine squared of a minus sine squared of a. There are actually 3 double angle identities for cosine of 2a, but they really are just rearrangements of this one using Pythagorean identities, but I want to show you those also. So I'm going to step 2 here. Couldn't I rewrite cosine squared as 1 minus sine squared? So I would get 1 minus 2 sine squared of a. So that's another identity for cosine of 2a. And there's one more, as you can imagine. Instead of replacing cosine with sine, I could replace sine with cosine, and I would get cosine squared of a minus 1 minus cosine squared of a, which would be 2 cosine squared of a. If you look at your trig helper, these are on there. These are called the double angle identities. The next one. Sine of 2a. What's the identity for sine of a plus a? Since those are all a, isn't that just 2 of those? So this is the double angle identity for sine. There's only one of those. Since those aren't squared, you can't use any Pythagorean identities. So there's only one double angle for sine. Remember how I didn't make you memorize the sum of difference identities?
Yeah.
I've never seen those show up on an AP exam. I have seen double angles show up on an AP exam, so you'll want to memorize the double angle. Okay, tangent of 2a. Tangent of a plus a. Tangent of a plus tangent a over 1 minus tangent of a, tangent of a. So on top you get 2 tangent of a. So these are the 3 double angle identities. There they are. Cosine can be written 3 ways, but I want to emphasize that, remember, that's just rearrangements using Pythagorean identities. Sine of 2a has one option, tangent of 2a only has one option. So these are the 2 identities we're going to be working on today. You already know how to work with identities. This is just a set. Okay, They're on your trig calculator. But you'll need them. Where are they on your trig calculator? Does anyone have it out? On the pink side, all some double angle identities. Double angle form. Okay, so how can we use them? So I know that sine of theta is 8 over 17. Cosine is less than 0. Find the sine of 2 theta, cosine 2 theta, and tangent of 2 theta. I have seen this on the ACT one time. One practice exam once. I don't know that it'll show up ever again, but good. So I don't know what theta is, so to find sine of 2 theta without a calculator would be very difficult at first glance. But what is sine of 2 theta equal to? 2 sine theta cosine theta? Do I know what sine theta is? Yeah, find what cosine theta is. And so pretty easy with the identity. I know cosine is less than 0, so what quadrant would I be in if sine's positive and cosine's negative? Cosine's positive in 4. Sine is negative in 3. 2. Okay, we gotta get rid of it. Y2. Up, sine's positive, right?
Yep.
And left, cosine's negative. So place those intersect as in quadrant 2. Sine is opposite over hypotenuse. What is that third side? Don't do that pretty fast. Good job. How many of you are taking the ACT Saturday? Do you feel like yesterday was helpful? Any questions so far? Multiply, and just every now and again I like to show you that we can multiply without a calculator, so I'm going to do this up here. How do you multiply 17 times 17?
You gotta add a 0 at the bottom.
17 times 7, and I get 7 plus 4, which is 11.
Put a 0.
Then what I'm really doing is 17 times 10, right?
Yeah.
As long as you do 17 times 10, I mean, the whole, what you're really doing when you say this, because I don't think you learn lattice and never learned this way, what you're really doing is you're separating it, multiplying it by 7, and multiplying it by 10, and then adding those together, because that's easier numbers in your head. So that's why this is what it is. If you like lattice, use it. I don't even know how to do lattice, so I can't help you, but it works. So 289 is the denominator. The numerator, I'm going to do 16 times 15. Does everyone know why I would pick 16 times 15? 2 times 8, so I'm going to do 16 times 15. So 5 times 6 is 30. I get 80 when I do 16 times 5, which you might have known that 16 times 5 is 80. And then I'm going to multiply 16 times 10. I get 160. So 240. So the top is negative 240. So we don't like to have to do it, but if you have to, you can. Any questions so far? Every now and again you'll have to do something like that. Find the values of the 6 trig functions. Oh wait, I didn't finish. I found sine of 2 theta. I also want cosine of 2 theta and tangent of 2 theta. I have options on tangent, but for cosine I'm going to have to do an identity. I will select my calculator just for speed at this point. But if we did one. So cosine of 2 theta. Which identity would you choose? would be best for this problem? 1 minus 2 sine squared. Why would I pick that one?
You already have sine.
Even if I messed up my triangle drawing, it doesn't matter because I have sine. So I would pick that one because it's not something I had to come up with. It gives me sine in the problem. The others would also work. So I get 1 minus 2 times, what was it, 8 over 17, thank you, squared. So 64 over 289 times 2, which is 128 over 289, is that right? And 1 minus that, which is 289 minus 116.
What?
Any questions about that one? You have 2 options on tangent of 2 theta. What could you do on tangent of 2 theta? You could do the formula, right? You could do 2 tangent of theta divided by 1 minus tangent squared of theta. That would work great. What else could you do since you have sine and cosine?
That's what we're calling the last stuff.
I could do sine of 2 theta divided by cosine of 2 theta. Does it matter which one you do? Does everyone agree that this is equivalent to sine of 2 theta or cosine of 2 theta using a different identity? And what was the sine of 2 theta? And I heard someone say, hey, you could take the numerators from each, because the denominators are the same, they will end up canceling when you flip and multiply. And you will get negative 240. Now, the denominators are not the same. Be careful about that. Any questions about that?
Hey, Bryce.
Hi,
Where you been, dog?
Lunch. I was really confused how they said it.
Find the values of the 6 trig functions of theta. So I'm going to find the value of the 6 trig functions of theta. See if you can come up with anything. Okay, so I have cosine of 2 theta. I want to find the original values of sine and cosine of theta. First of all, couldn't I write an equation that has cosine of 2 theta in it with something else in it maybe solved? Okay, so pick one. What is identity for cosine of 2 theta?
No, ours is 80.
Okay, 1 minus 2 sine squared theta. If I use this identity, what is it going to help me find? It's going to help me find sine. What if I wanted to find cosine? You do the one with cosine. The other one's not going to help find anything, is it? Because it has too many variables and it would have sine and cosine. I would have a hard time finding something from that. So one of these two is a good place to start. This is negative 12 over 13. Can I solve that for sine of theta? Subtract 1. Which gives me negative 25 over 13. Is that right? Divide negative 2. Gives me negative 25 over 26. A positive 25 over 26. And what about sine? Square root both of those. Does everyone agree? Plus or minus? Really? What's going on?
I have no idea what's going on.
Okay. So I took this equation. You know where I got that?
From our chart.
Okay. I put negative 12 over 13 in for cosine squared. And now I'm getting sine squared by 12.
Where did you get this
equation?
Yeah. Oh. That's good. It makes sense. Yeah, it's a D.
Good now?
I'm good.
Okay. Now, plus or minus? Which one?
No, it says right there. Yes. Plus. It's actually minus.
Minus.
Why minus? Why not? The angle is between 180 and 270, which is down here, right? Have you really agreed?
Yeah.
So that's in the third quadrant. What is sine in the third quadrant? It's negative in the third quadrant. So even though originally it looks like maybe plus or minus, it is the minus. And are y'all okay if I go ahead and write it this way?
Yes. Yes. That makes sense.
Just rationalize.
I thought you said after that one section we won't have to do that anymore.
No, in calculus. No, we're still in street. And you'll still need to know how to rationalize through. You still need to know how to rationalize because to match multiple choice answers. But on open response, you don't have to in calculus.
I just drew this blue.
Yeah, big Drew and little.
I'm Drew number 1.
That's true.
Distracted. Okay, we ready for the next? What else are we supposed to find? We're supposed to find cosine and tangent also. What would you do from here?
Plug them in. So the triangle.
Okay, you have options. You can either draw a triangle, or you could do the same thing except with the cosine identity, right? It's up to you. Now, after the cosine identity, you're going to have to draw a triangle. So, in my opinion, I'd say why not go ahead and draw it now. But if you just wanted to make sure you were doing it right, you could try the cosine one as well and get the cosine back if you wanted to. You can draw the triangle from either place, but I would highly recommend drawing a triangle from the unrationalized form. Just make your numbers a little easier. Both one will give you the correct answer, but the unrationalized form will be a little easier. So opposite is 5. Hypotenuse is the square root of 26. The 5 is negative because we are going down.
Yes.
And how will I find the other side?
Pythagorean theorem.
Pythagorean theorem. So I have this
26.
square root of 26 squared is 26 equals 25 plus b squared. So I get 1. Positive 1 or negative 1?
Negative.
It's on the third quadrant triangle. It's negative 1. And so now I can find cosine and tangent of theta pretty easily.
Yes. Blocks. You can do that on the last one too, but you just have to plug it in the equation and stuff.
As soon as I get one of the... Now, actually, the only thing I have to... On this one, I did have to go ahead and find 2 of them. I had to find cosine also, because I don't know what quadrant 2 theta's in. So I wouldn't be able to choose plus or minus on that. You know what I mean?
You just guess.
I mean, if that's how you like to live your life, I suppose. But... one that looks complicated.
Yep.
Does it look like an identity?
No.
Which identity does it look like?
Cosine.
Two cosine squared theta minus 1, right? So let's break the identity up so we don't have any, where in the world does this equation come from thoughts? Cosine of 2 theta, is that correct? So that's what we're looking at? Equals 2 cosine squared theta minus 1. Everyone agree? What's our theta?
5x.
5x. So what is this equal?
2 cosine squared theta 5x.
Why is it equal to cosine 10? Is that simpler for graphing purposes?
Yeah.
Yes, I have no idea how to graph 2 cosine squared of 5x minus 1, but I'm pretty sure I could graph a cosine graph with just a period change. So that's a lot simpler. It's also a lot simpler as far as derivatives and integrals go, which is calculus in your future. So that's where that would come into play. Is it simplified it a lot, made it something we can deal with.
Hey, where's your squared minus 1 here? Oh, okay, I got it.
Oh.
Any questions so far? Hey, let's look at the next one. What identity does it almost look like? It doesn't quite look like it, but what identity would we at least try to pull up? Sine of 2 theta equals 2 sine theta cosine theta. Correct? But I need to rearrange that identity to be able to use it. What do I need to do to make it look like this one?
You have to.
Divide both sides by 2, because right now that format of the identity doesn't quite match what I have. So I'm going to divide both sides by 2 in the identity. So that also means that sine of 2 theta divided by 2 equals sine of theta cosine theta. Do what?
Never mind. You're giving up on such stuff.
I really didn't hear you. If you have a question, you should ask.
I don't think you wanted to.
I'd like to encourage it.
Yeah, I really do.
Take out.
You have to divide both sides. Alright, so let's look. What is our theta? 165 degrees. So what's 2 times 165 degrees?
Hold on.
330.
Sine 330. It is, isn't it? It is a number. Negative 1/2 is everyone know where they got that from. 330 is a 30-degree angle in quadrant 4. So you draw a 30-degree reference angle in quadrant 4. So all of that is just negative 1/4. It's that simple. Very much so, right? It is a lot prettier. So this is what simple angle identities can do for us. That's kind of the same thing that we're doing. Okay. So let's look at this one. See if you can do this one. Cosine 2 theta. So what is cosine? What is the theta in this? 15. So 2 times 15 is, and what is cosine 30?
33.
Any questions about that one?
That's not a question about the problem. Sit about.
Hey, of course with double angle identities we can do proofs. So I have a proof up here with a double angle identity. What do you do on a proof? You just now have some more identities. Pick a side. Go to the left. Okay, what could you do on the left? You can factor it. It's the difference of perfect squared. Cosine squared of theta minus sine squared of beta. Cosine squared of beta plus sine squared of beta.
Both equal something.
Bigger.
Cosine,
Oh, there one.
cosine, q squared.
Oh, there equals cosine. Yeah, okay. Okay.
So okay.
We win!
Woo!
That was so easy. Wait,
Any questions about that?
Add you.
Sine squared.
Oh.
True.
Okay. Your homework. Is this page and the worksheet both in my I'm going to do worksheet. This and the worksheet both due Monday. 2 through 8. 2 through 8. And also 42 through 48. That's not very many problems. 4, 5, 6. It's 10 problems up there. It looks like a lot more than it is. I got it. You